Dream to become the next Sir Isaac Newton or Albert Einstein? Learn calculus from Refath Bari, aka 800/800 guy, is teaching calculus this year. Watch his videos.
Alright folks, what's up? This is Refath Albert Bari from Bari Science Lab. Today I'm going to be doing a few more product rule examples because I saw a couple of you guys don't understand what I'm doing when I'm doing the product rule. So let's go ahead and get started with the actual definition of what the product rule is. Well, if we have a function, let's say f of x, and we define that function as the product of g of x and h of x, then the derivative of this function f of x, denoted as f prime of x, is simply going to be the sum of this, the derivative of g of x times h of x, plus the derivative of h of x times g of x. And that, folks, is the product rule. It's a product rule, right? And this product rule really helps us find the derivative of really any functions that are the product of two other functions or two other terms. So let's use that knowledge to our advantage. Let's try to solve these two problems. The first problem is pretty simple. We have to find the derivative of this polynomial. So let's erase all this definition right here. Okay, so the first question we have is to find the derivative over dx of 4x cubed plus 2x squared. So the first thing we're going to do is expand this, right? So if we expand this, we're going to get 4x cubed plus 2x times 4x cubed plus 2x. Now all we have to do is apply the product rule, right? So we're going to find the derivative of 4x cubed plus 2x, multiply that by 4x cubed plus 2x, and then we're going to add that to the derivative of 4x cubed plus 2x times 4x cubed plus 2x. Right, so because we have two like terms, we can simply combine them, and I'm going to rewrite this as 2 times the derivative of 4x cubed plus 2x times 4x cubed plus 2x. Okay, so we're almost there. Let's find the derivative of 4x cubed plus 2x. Using the power rule, I know that 4x cubed is simply going to become 12x squared, right? Again, the derivative of a sum is the sum of two derivatives, so I can use that to simply write plus. The derivative of 2x is simply its coefficient, 2, and I'm going to multiply all of this by 4x cubed plus 2x. Now all we have to do is simplify this, right? Simplifying this, let me just go ahead and distribute the 2. So that will give me 24x squared plus 4. And now all you have to do is FOIL. I'll just finish it off, right? So that we can get an answer. 24 times 4 is going to give us 96. Let's write it over here. So 24x squared times 4x cubed, 96x to the 5th. So that's over with. 24 times 2 is going to give us 48x cubed. Now let's do a 4. 4 times 4x cubed is simply 16x cubed. And our last term is going to be 4 times 2x, which is simply 8x, right? Okay, we're almost done. Let's combine the like terms, and that's it. Our final answer is going to be 96 times x to the 5th plus 64 times x cubed plus 8x. And that, folks, is going to be the derivative of this function, 4x cubed plus 2x squared. Okay, so question 1, we've done our first example. Let's go ahead and complete the second example. Now the second example is a bit different in that not only do we have to find the derivative of this function, but we also have to find the tangent line to this function at x equals 1. Now if you recall, finding the tangent line is analogous to finding the derivative. So we're really doing the same thing here. So once again, the first thing I'm going to do is try to apply the product rule to this function. So how can I do that? Well, let's first write out the function d over dx of, let's distribute this 2 to x to the 4th and x squared. So I get 2 to the x4 minus 2x squared times 2x cubed plus x. Alright, great. Remember, we're trying to find the tangent line of this function at x equals 1. So keep that in mind. Okay, let's proceed. Remember, the product rule tells us the product of two derivatives is the derivative of the first term, times the second term, plus the derivative of the second term times the first term. Okay, and that's the product rule, right? Now let's just find the derivatives of these functions, of these terms. So, using the product rule, 2x to the 4th becomes 8x. Remember, the product rule tells us that if we have a function x to the n, its derivative will be nx to the n minus 1. Applying that rule here, we get 8x to the third power. So 8x cubed. Same concept here. 2x squared becomes 4x. 4x. Let's apply that here. 2x cubed becomes 8x squared. And what else do we have? X, of course, the coefficient of x is 1, and that will be its derivative. Okay, so we found the derivative of the functions, and now all we have to do is FOIL it up, right? So let's do that. Okay, so that will give me what? 8x cubed times 2x cubed is 16x to the 6th. 8x cubed times x is simply 8x to the 4th. Minus 4x times 2x cubed is what? Minus 8x to the 4th. So already we have something to cancel. And minus 4x times x is simply minus 4x squared. Right, we're done foiling the first two terms. Let's go ahead and FOIL the second pair of terms. 8x squared times 2x to the 4th. Let's get the algebra right. We've got 8x squared times negative 2x squared. So that becomes a negative 16 to the 4th. And then we're multiplying this by 1. So let's just write this out. Plus 2x to the 4th minus 2x squared. Alright, what can we cancel? Right ahead, go ahead and cancel x to the 4th. Right? Is there anything else left to cancel? I don't know. I don't think so. So let's go ahead and add up these like terms, right? 16 plus 16, that's going to give us a 32x to the 6th. Minus 16x to the 4th plus 2x to the 4th is going to give us a minus 14x to the 4th. So we're done with those two pairs. And now we're left with minus 4 and minus 2, which becomes minus 6x squared. And remember, we're trying to find what are we trying to find? We're trying to find the equation of the tangent line of this function at x equals 1. So, first thing we're going to do, we're actually going to plug in 1 into this function so that we can find out the y-coordinate of this point. So let's go ahead and do that. Let's bring this function over here. 2 to the x 4th minus x squared times 2x cubed plus x. Now we're just going to replace x by 1, right? And it seems we're going to get 0, right? So that means we're trying to find the tangent line of this function at 1, 0. So now all we have to do is actually find the slope of the tangent line. Okay, So how do we do that? Well, we found the derivative of our original expression, which you can see is this. And now that we found the derivative, we're just going to go ahead and plug in 1 for x over here. So plugging in 1 for x, we get 32 minus 14 minus 6. Go ahead and compute that. That's going to give you 12, meaning that the slope of our tangent line is 12. And we already have a point, which is 1 comma 0. So now go ahead and use the point slope formula to actually find the equation of the tangent line. We know the slope of the tangent line is 12. So just go ahead and plug that in. What else do we know? We know the y1 of our first point is 0, right? And we know our x1 is just 1. So the equation of our tangent line becomes y equals 12x minus 12. And that, folks, is how you use the product rule to find the tangent line of a function at a certain point. So thank you for watching, and we'll see you next time.
To fall in love with math and science, especially programming.